Okay, it's been 30 seconds, but I'm going to get started because we have a lot to get through, and it's okay if you miss on the who and where from. So, hello, my name is Lev, and looking forward to diving into our second lightning lesson in our series. For those of you who don't know, this is a three-part series actually, delving into different stages of the AI integration pipeline, and this is session number two. So, last week we covered how to prepare your data for integration, so kind of setting the stage. This week we're actually delving into the meat of the matter and talking about how to integrate Gen AI capacities into your existing software systems and how to actually build the thing. And then next week, we're going to talk about how to tweak the style and delivery method of the model to user feedback. So that's kind of like what you do right before launch or after launch once user feedback starts trickling in. Uh, so my name is Lev. I'm joined here by my colleague Jeremy. And to set some context, why should you listen to us? We are founders of an AI software studio called Handshake. And what we do is specialize in highly customized generative AI applications. Our work often involves as much consulting and discovery and teasing apart how people do, how our clients do what they do, as it does in actually building AI software. And the reason why so much time is devoted to discovery and interviewing and getting into people's head is because what we aim to do is replicate a company's unique voice. And this is like what you see on the screen right now is the different platforms we built. They range from nonprofit chatbots to um, um, personality assessments and interviewing tools to these kind of Wikipedias of the future, which do 10-year forecasts according to a very specialized methodology of 10-year forecast of any subject matter you type in. So instead of Wikipedia, what gives you current information on a topic, you type it in, and it gives you what that subject matter would probably look like in 10 years, or would be speculated to be looked like. I encourage you to go and check out whatifpedia.com. It's a great representation of what we do. What all of these things have in common is we try to dig in to the company's culture and methodologies, and most of all, what we call knowledge craft, which is a term that I think we came up with. So don't worry if you haven't heard about it before. And it's quite a difficult term to define in a single sentence, but you'll get a better grasp of it by the end of the session. We drilled it into it a little bit in the last lightning lesson. If you weren't there, don't worry about it, because if you are in this lightning lesson, you'll get a follow-up email with the recording to the last one. But to set the groundwork, what we mean but when we say knowledge craft and knowledge work is something that is at the intersection of business intelligence, so like information, tribal knowledge, so like cultural information, and something that isn't explicitly stated but intended to be known by each team member, and proprietary methodologies, so like concrete ways for arriving at a certain deliverable. In knowledge work, if I had to put it in a single sentence, it is kind of like the way your company goes from raw information to insights that your clients value in your company. It involves both explicit and implicit content. It involves both methodology and style. It involves both art and science. So this makes it pretty ambiguous, but basically, as I said, it's whatever you do in order to get from raw information coming in into something that your company, you get your clients are ready to pay money for. Um, Now, the trick of change management and managing AI innovation is that you have to document how you execute on knowledge work in very, very thorough detail in order to convey that process to generative AI and successfully automate your knowledge work with generative AI. And in our course, we teach you the full skill set and tool belt on how to scale and revolutionize your knowledge work with generative AI. So here today, I'll be providing the conceptual bedrock of integrating Gen AI into information flows. But unlike today's session, the course is way more than just armchair strategizing. Half the class is actually hands-on building the workflows that align with your unique approach and ways of doing knowledge work. And you kind of half buy a course and half hire us as consultants in order to help you and guide you in prototyping the way you mint insight in your company and prototype that in a generative AI application. So you walk away with a unique takeaway, which is the your unique approach of how you do knowledge work in your company embodied in an AI system. So that was my plug. Thank you for indulging me. Let's get into the actual interesting content. Let's start by bursting a major bubble about AI superiority. What I'm talking about here is this myth that AI is posited to outperform all traditional software. And the myth that when in doubt, lean on generative AI to solve your problems. As ourselves peddlers of AI, we vehemently detest this myth. It forces us to spend a big chunk of our initial engagement with clients, bringing them down from the clouds and shaping realistic expectations, and figuring out where generative AI is actually going to bring them value. Because the reality is, AI is not perfect for everything, no matter what the advertisement says. I'd go even further. Turns out generative AI is actually good at quite a narrow band of use cases. Now, credit where credit's due, it is exceptionally good at those use cases, and they're tasks we could have never achieved with machines before until Gen AI came about. But with that silver lining stated, this does not make Gen AI the silver bullet for all your problems. There's actually tasks that generative AI is uniquely positioned to do well, and all other tasks where legacy systems or traditional software, in other words, is still very well positioned to outperform Gen AI in. Now, with that, I'm going to turn to my colleague Jeremy Kirschbaum to differentiate those two buckets for you.
Yeah, thanks, Lev. So this gets obscured by the fact that today's chatbots are a combination of both generative AI models and legacy deterministic computing. So for older kinds of computing, we're accustomed to things that are really fast, like milliseconds fast, and things that are really cheap, like fractions of a cent cheap, um, as well as things like arithmetic, which they're quite good at. And that they're very good at interfacing with real world systems as a result. Generative AI is really good at things that are different each time, um, that are generative. So this could be things like developing ideas, although it's not good at facts. It takes a lot of work to get it to be factual. Writing or understanding natural language, which is the unique power of generative AI that deterministic software can't do. Qualitative reasoning or analysis, or understanding and generating code. But these things come at a big cost. They're very expensive, they're very slow, and they're very difficult to scale. And so you should only ever use generative AI models when you specifically need these capabilities. For anything else, if you want it to be fast or to be the same every time, that's really wonderful. There's just 50 years of computing techniques that you can use besides generative AI models. Next slide. So even without, so in today's chatbots, if you ask for a numerical calculation like arithmetic or a spreadsheet or something, it's not actually the generative AI model that does it. The generative AI model will take in your request and then reach out to a tool that it has. So it'll use like a calculator, or it'll use a Python interpreter or something, because they've gotten good enough that they know that they're not good at this. Despite this, like you can do some deterministic calculations with them, but you just wouldn't want to. It's a little bit like having your CEO doing your accounting. Maybe the CEO could do the accounting, but the CEO's time is extremely expensive and the accountant is still better at it. Or in other words, don't fly your airplane to the grocery store. Generative AI models are particular and very powerful at a specific thing. And for anything else, you want to hand off to other simpler, older tools.
Right. Thank you, Jeremy. So with that grain of salt being stated, there are things that traditional software is better at. There are things that generative AI is better at. But of course, the best of both worlds is having them work together. Don't replace older tools with AI. Plug them into generative AI. Let the model act as kind of like a traffic control tower using other software as it sees fit. when creativity is not needed, when keyword search outperforms semantic search, or when math is involved, give a model the choice to offload these things to external systems by itself without your guidance. And this is kind of going to be the focus of how you would approach this on a managerial point. We're not going to delve into the code and the nitty gritty, but like strategically, how would you approach in connecting generative AI with traditional software and making them work together? So, of course, making these two worlds collaborate, there's a price to pay. And what I'm talking about is a very serious logistical challenge in the change management of AI innovation, and that is to how to bring your unconscious decisions and actions in your knowledge work to the light. So, for example, let's say you're writing a thought leadership blog. If I ask you how you do it, you'll probably list these things. You read articles, you identify consistent themes, you collect certain articles that are most insightful, you come up with several ideas on what to write about, and so on and so forth. Now, that first step, if we just take that first step, it actually involves a lot of unconscious and subconscious steps that you've taken in order to execute on it, but you've never actually explicitly stated them. So, what search engine do you use? What source data do you use? When you found the search engine, how do you what words do you use, and how do you choose the words necessary to explain what you're searching for? When you finally did the search and you've seen the post that came up, how do you choose which post you clicked on? When you clicked on a post and saw the content, how do you know what content to actually look for within the information you just picked up? And even that first sub-step, if you are trying to convey to traditional software that's not AI, there's still a lot of steps you need to elucidate further. Like, how do you query it? What is your API? How do you where is how do you convey to the API that what you're trying to do is a search and not something else? What this process is generally called is called task decomposition. And the problem it solves is that many steps that we take are made unconsciously in our heads, and as a result, when we convey these instructions to the model, we leave a lot of things ambiguous and up in the air, and then we are disappointed when the model does not do the way we do and does not meet our quality standards. Like when you convey this to an intern or somebody you just hired, of course, when you instruct it to look things up in Google, it'll hark back to its years of experience in the field in order to look for relevant information. But the kicker is, to the model who might know the entirety of the internet but is not specialized in your specific field, what information is relevant is not obvious by any means. And you never have to put in words these very explicit things that you do. And now, if you want to embark on the AI innovation, you do need to go into this unique type of introspection and really get maximum clarity how you perform these tasks. What I find empowering about this is it's probably something, if you're a project manager or an exec, it's probably something you've been wanting to do anyways. It's like document how exactly your processes execute. But you never got to it because it's a back burner task and your client needs something by tomorrow. The great thing is all the information is already there. You don't need an AI expert like us in order to do this step. You don't need additional information from the outside. All of it's hiding in your collective conscience as is. So the clarion call is upon you to bring it out of your team's unconscious or out of your unconscious and get it down on paper in an as explicit state as possible. Leave as little as possible to ambiguity. Don't assume anything. Try to write down how you do what you do in the best, most clearest way you can imagine. Okay, so you've done that part. What is next? How do you actually convey this to a model? So what you'd want to do is create like a whiteboard decision map that looks like a set of nodes. Each node performs some aspect of that task that you've just documented for yourself, and then pass it off to the next node based on the specific knowledge, specific logic. So what I'm showing here is the most generic version. It's a user describes something, goes to a supervisor, which delegates it to a team of agents. Um, so let's break this down here and kind of hang in on this concept a little more because to some of you folks, it's very new. So first node is obviously the user explaining what they want and elucidating to you their desires. Then, through task decomposition, you gain an understanding of all the tiny steps you take in order to address that user's need in a unique way that is unique to your company. Now, let's move towards how you would automate this with AI. Instead of having one language model with one set of instructions executing on that user's desire, you set up a supervisor who accepts what the user wants and decides from a set of other language queries which one is best to deliver on the user's desires. If I lost you there, let me just dig in a little more because I'm using words like queries and language models, and that's if that's new to you, don't worry. So let's start with something you're probably familiar with. I'm guessing most of you who use ChatGPT or Claude, and you type in like some question and it gives you an answer. Um, what you don't see is when you send that question to OpenAI or Claude or whoever, the provider actually appends additional instructions to what you said for the model. So these could be like respond in English or respond in English and respond in the language in which you were addressed. Don't be racist. Remain politically neutral and don't get into hairy situations. Those additional instructions make the model respond better and intuit better what you want from it. What I'm saying is when you build your agent team, there's a few additional steps between the user explaining what they want and the model giving it back a response. In the workflow you'd want to build after task decomposition is the user asks a question like, "What is your company's return policy?" Or if it's an internal tool specifically intended to be used by your internal team, they might ask like, what past content in our database is relevant to the blog post I'm writing? So instead of that going to an LLM and LLM just giving it a response, what happens is that goes to a large language model, which is the name for AI that generates text. Um, and instead of just saying like don't respond in a different language and don't be racist, instead it goes to an LLM whose instructions is this is what the user wants. Your job is you have a team of experts. Each one does this or that. Which expert is best specialized to address that user's need? And so the supervisor node, what it does is it delegates a task to the expert best suited to address that specific user's need. So, for example, if it's a question about return policy, the supervisor might decide, but the internal database specialist that has access to your company's Google Drive or your company's, I don't know, Microsoft Office suit, that expert might be best to dig up your return policy document and find out what is your return policy right here and now. Or it might be a spreadsheet analyzer that crunches through your Excel sheets and digs up insights from there. Or it might be a coding specialist that creates some kind of widget. Whatever it may be, the first LLM decides, okay, so since this person is looking for relevant information on return policy, I'm going to send it over to an internal database specialist, which will search through my Google Drive. Then the user's instructions are sent to that expert. So the expert's like, okay, so the user wants return policy information. I have access, I'm a specialist in Google Drive of our company. I'm going to dig through the Google Drive and dig up the return policy of our company and send that back to the user. That information gets sent yet to another query to your large language model, which gets fed the information from Google Drive that is relevant, and then elucidates to the user in a specific way what insight it has garnered. So instead of using a large language model once, you use it 3 to 4 times. And by splitting execution into these discrete steps, you more faithfully replicate your human processes in generative AI processes. And this comes with multiple benefits. The benefits of using multiple calls, even though it's more expensive, it's slower. The benefit is one, it better reflects how your experts actually perform their work. Your experts never get one set of instructions and just do it. They do one thing, they make a set of decisions on how to best respond to the user. They reach some conclusions, and they're like, okay, so I made some insights onto what the user wants on a return policy. Now, based on what I know at this point, I'm going to make some new decisions and new choices and look in another place in order to answer that question even better. Um, the second benefit of this is if the model works only with the data that it needs to answer that specific question. It doesn't start coding things up unless it needs to code. It doesn't start looking up in Excel sheets unless number crunching and specific numerical takeaways is what it needs. It looks in Google Drive only when it knows that it needs to look in Google Drive and doesn't waste its potential. So it's an optimization step. And in addition, there's other logistical benefits, including it's way better at debugging this kind of process as opposed to a single set of instructions. If the agent hallucinates, you can look up, okay, so did the supervisor mess up on who it delegated the task to? Did the agent mess up on where it dug the information from or what conclusions it made? And it's way easier to change the system in order to address the user's needs better. Now, I did use supervisor to agent system as an example, but once you get familiar with that concept, there's actually a lot of other ways that you can choose to branchiate or coalesce your workflows that better reflect how you do what you do. I just chose supervisor to expert kind of handoff because it's most familiar to us as humans. Okay, so that is how you would delegate the how, sorry, the when to use specific tools. Now for the how. So let's switch focus here a little bit. Um, by building up this kind of nodular workflow, as I said, that's how you embody the when. So when do you turn to Google Drive? When do you turn to Excel? When is the best context in which to address the user's needs? So what users need would need Google Drive, what users need would need Excel sheets. You embody that through the nodular workflow. Now let's talk about the how. So how would you actually start using the Google Drive or the Excel sheet or your whatever other software you have in order to address that need? And in order to convey the how to the AI model, how to use your concrete tools, we use something called MCPs. You can think of MCPs as something like as a USB-C port for plugging in generative AI. You might remember there was an era when every new gadget came with its own plugin and its own port, and whenever you travel anywhere, you just bring this like sponge of wires, and only you knew what port would go to which cell phone or iPod or whatever. And then came USB-C, and thankfully universalized the way electricity and data travel from device to device. Well, this is a good analogy for what MCP does to generative AI. Without MCPs, every tool and software requires its own programmatic language in order to communicate with AI. You have to create a unique connection for each new data set or software for AI to communicate with. And this raises the complexity demand exponentially. So if you have n amount of AI software like Claude and OpenAI, and you have an X amount of company tools, then the amount of bridges you need between model and tool is rises exponentially. And if you want to switch to a new AI provider or plug in a new tool, well, now you have an exponentially more amount of connections to make. And everything I'm saying about data connections likewise applies to any software that you want to connect to to generative AI. So be that proprietary software or calculators, emails, or whatever. MCPs go a long way in standardizing. They act as a universal bridge between AI models and any external port. And there's a growing community and a great plethora of pre-built MCPs out there. So if you're connecting your company information to Google Drive, there's already an MCP out there built by a very great well-informed folks on how to plug in generative AI into Google Drive. You just need to give it your credentials, and voila, you're set to go. And as I said, you can swap the model from OpenAI to Claude to Gemini, and you don't need to change the MCP. The MCP will handle the switch of provider for you. And as an added bonus, it'll handle the authentication error management. So if Google Drive sends back an error, MCP will convey to the model, to the AI, hey, we got this error, and actually know how to solve it. Do this, this, and that in order to resolve this kind of issue. So another great bonus is no vendor lock-in, so you can switch out between different providers or different tools from the Google Drive to Microsoft Office uh, package without having to completely reinvent your whole software integration, and AI will just automatically know how to handle that switch. And it just gives more agency to the model because MCPs explain explicitly to the model what that tool or a database can do for it. Um, so like when the model has like one or multiple MCPs in its purview, it knows, okay, so I can do this with what I have connected to me. I can do that with what I have connected to me. So when a user request is relevant to that specific task, I know I have this MCP which connects to Google Drive or whatever. I can reach to it and it'll do it for me. I don't have to just spit it out of my head. Um, so to reiterate and summarize, what pain points do MCPs address? They are not recreating the dynamic of your team. They are stabilizing the way a specific model communicates with a specific tool. Um, Without MCPs, the model is like will likely just use whatever database or tool you plug into it, regardless if it's relevant or not. It's just like, oh well, they gave me this Google Drive. I don't know if it's relevant or not. Whatever the user asks me, I'm going to be reaching into that Google Drive. MCP is used as a plugin. The model's like, okay, so I have this Google Drive. Is it actually relevant to what I'm trying to do for the user? No. Okay, I'm just going to disregard it and just wing it on my own. Yes. Okay, I know exactly how to speak with that tool and use it in order to address the user's need. Um, and additionally, it just introduces more modularity. You can swap things in and out more easily. Now, I know we're almost at time. I dumped a lot of information. I didn't need to leave you space for questions, which, by the way, I'm going to be here for an unlimited amount of time after a half an hour is done to address as many questions as you want. But let's just like summarize what I went through in the last half an hour in a specific workflow and concretely address the subject matter of today's session, which is how do you integrate traditional software into your workflow? Well, to answer that question, first, break down the way you currently perform a task as humans. Digest it into the most atomic and smallest logic gate steps as possible. Document what reasoning you engage in whenever you make some kind of decision, whenever you decide to use that or that tool or this or that data set. Make as much explicit as possible. Once you did that, identify actions which demand creative input. Identify where traditional software can't do it. And whenever traditional software can do the job, default to traditional software. Don't